A hemispherical bowl is filled to the brim with juice. The juice is poured into a cylindrical vessel whose radius is 50% more than its height. If the diameter is same for both the bowl and the cylinder, then find the percentage of juice that can be transferred from the bowl into the cylindrical vessel. So this is the question. So if you look at this question, there is nowhere mentioned about any measurement of the cylinder or about the hemispherical bowl. So this is a general question where we are going to prove that the volume of the hemispherical bowl and the volume of the cylinder are same for this particular case. Okay, imagine if you are having a cup filled with juice. A cup, it's nothing but a hemispherical bowl. Okay, we are transferring this juice into a cylindrical vessel, say a tumbler. Okay, a tumbler looks like a cylinder, right? So we are transferring it to the cylinder. We are going to identify what quantity of the juice can be filled in the cylindrical vessel. That is, what quantity of juice can be filled into the tumbler. That's it. So this is the question. So we are going to say the quantity of juice in the bowl and the quantity of the juice in the cylinder are same. That is, the volume of the cylinder and the volume of the hemispherical bowl are same. This is what we are going to prove. Okay, so let's just imagine a rough images of the hemispherical bowl and the cylindrical vessel. Okay, so imagine if this is going to be a hemispherical bowl, a cup. Okay, and imagine a cylindrical vessel, say a tumbler. Okay, now look at the general instructions given about the cylinder and about the hemispherical bowl. The juice is poured into the cylindrical vessel. So the juice is poured inside this tumbler whose radius is 50% more than its height. So this is the radius. So this radius is 50% more than its height. This is what is mentioned. So the radius of the cylinder R is equal to height plus 50% of height. Yes, this is the general thing given. With this, we will identify a relation between the radius and the height of the cylindrical vessel. Okay, so R will be equal to H plus 50%, that's nothing but 50 by 100 into H. Okay, so this is H plus 1 into H by 2. H plus H by 2, that is R is equal to 2 into H, 2H plus H by 2. That is R is equal to 3H by 2. So this is the relation between the radius and the height of the cylinder. Okay, with this, okay, we are going to find out some relation, that is, we are going to say that the volume of this hemispherical bowl and the cylinder are same. Let's go back to the question now. We have got some idea with the first condition. Now look at the next condition. If the diameter is same for both the bowl and the cylinder. Okay, if the diameter is same for both this bowl and the cylinder. So diameter in the sense, this entire thing, this diameter D is same for both the hemispherical bowl and the cylinder. Okay, what can we say about the radius? The radius also will be same, right? So if we are denoting the radius of the cylinder as R, how about the radius of the hemispherical bowl? That will also be denoted as R here. Okay, so we have identified the radius is same for both the hemispherical bowl and the cylinder. Okay, now let's write down the formulas for the volume of the hemispherical bowl and for the volume of the cylindrical vessel. Because what is the question? If the diameter is same for the bowl and the cylinder, then find the percentage of juice, that is the quantity of juice that can be transferred from the bowl into the cylindrical vessel. What quantity is transferred into the cylindrical vessel? So quantity in the sense it is definitely understood that we are going to identify the volume. So let's identify the volume of this bowl and the volume of the cylinder, and then let's decide what has to be done. Okay. So first thing, volume of the hemispherical bowl. Okay. Volume of the hemisphere, the formula is 2 by 3 pi r cube cubic units. Right. How about the volume of the cylinder? That will be pi r square h cubic units. Okay, fine. So now this is the general thing which we are having now at current. Okay, radius is r here, here the radius is r and the height is h. With this, we cannot even say what quantity of juice is being transferred from the bowl into the cylinder. Okay, so we are going to do some alterations. What alterations? We are having a relation that r is equal to 3h by 2. Yes or no? So, with this, let's find out what is h. From this relation, we are going to identify what is h. So have h alone here. 3 by 2 is a fraction. If it goes to the other side, it goes as 2 by 3. So we have got a relation that h is equal to 2 by 3 r. Okay. This h is equal to 2 by 3 r for the cylinder. Substitute in the volume of the cylinder formula. This is nothing but pi r square. In the place of h, we are going to substitute 2 by 3 r. Okay. So what happens to this? We'll have 2 by 3 the fraction front, pi next, r square into r cube, cubic units. What is this actually? The volume of the bowl, yes or no? So this is equal to the volume of the bowl. What are we having now? The volume of the cylinder is equal to the volume of the bowl, which means the quantity of juice in the hemispherical bowl is exactly transferred into the cylindrical vessel, which means both their capacities are same. This is what we conclude here. Hope you all understood this simple proof. Thank you.